Okay, well, thank you again for joining us in this late January webinar. We are excited to bring some information from the USDA Midwest Climate Hub, and today we have Josh with a presentation for us here. Josh received his bachelor's in atmospheric science from UW-Madison and then got his master's in agricultural meteorology, so cool, from Iowa State. Prior to working here at the Midwest Climate Hub, he was a conservation specialist with Pheasants Forever and NRCS. We have people from that here on the call today. And he worked in the southeastern portion of Wisconsin with farmers to adopt grass-based conservation practices. So that work experience and his education really give him a diverse expertise that he's able to bring to us today and through this work. He is originally from Southwest Wisconsin, and his family grows grains, forage, and maintains woodlands as a wildlife habitat. So cool. So Josh, I'll throw it to you to present, and then we'll have a little break after this presentation for us to take a quick poll and to stretch. Josh, take it away.
Yeah, thanks so much, Aaron, and thanks everybody for tuning into this webinar today. It's a privilege to get to speak with you here today. Like Aaron said, my name is Josh Bendorf, work for USDA Midwest Climate Hub. See a lot of familiar faces on here today from both this role and my previous role with Pheasants Forever. So excited to see where this conversation goes today. I will just point out I have a few of my colleagues who are going to be helping answer questions in the chat and then can also chime in during our discussion time. But without further ado, let's get into it. Advance my slides. There we go. So our agenda for today, we're going to first go over a background of the climate hubs and the work that we do. I'm not going to assume that anyone here has a great background or knowledge of what the climate hubs are. So I want to just briefly go over that. Then we'll go over some climate trends and projections for Wisconsin, and in particular, eastern Wisconsin. Then we'll talk about some farmer and advisor resources to navigate climate impacts at the farm level. And then some adaptation mitigation options for Wisconsin farmers. So a lot of information to cover in a short amount of time. I understand that. I might go through some things pretty quick, but we have lots of time for questions and discussion after this presentation. And feel free to post things in the chat as they come up. So what are the climate hubs? Here's a map of the climate hubs and the different coverage regions across the United States. Here in Wisconsin, we're actually in a unique situation where we're actually covered by two climate hubs. So the climate hubs are either part of the Forest Service, the Ag Research Service, or NRCS. The Midwest Hub is actually part of the Ag Research Service based at Ames, Iowa on Iowa State's campus. I live in Southwest Wisconsin near to where our family farm is. I work remotely. But we cover a wide area, more than just Iowa. From Minnesota down to Missouri over to the Great Lakes states, there's 8 states that we at the Midwest Hub cover. We tend to focus more on issues of ag and climate. And we have our partners at the Northern Forest Hub up in Houghton that cover the Midwest and Northeast and actually focus on issues of forestry. Obviously, we have lots of forested and agricultural lands in Wisconsin, so it's really great to have this synergistic relationship between the Midwest and Northern Forest Hub. So what do? We provide a lot of technical support, both to USDA agencies and a lot of partner agencies, such as Extension, for example, facilitating engagement, discovery, and exchange of information. Like we're doing today, outreach and education, helping you all make climate-informed decisions on the operations that you manage, or if you're an advisor, the farmers that you help advise. And then assessments and syntheses of climate information. There's so much information and data out there, a lot of research. We're trying to find ways to package that information in a way that's going to be useful for practitioners. So now let's get into some of the climate data, temperature trends. So here are a few graphs, and these are from NOAA, the National Oceanic and Atmospheric Administration, their climate at a glance tool. And basically what these graphs are showing, those orange dots are averages of all the meteorological measurements across the state of Wisconsin, or just east central Wisconsin in the case of that bottom graph, for that individual year. And so what we're looking at is how measured temperatures for the whole year are changing over time since we began keeping records back in the late 1800s. As you can see in both the state level chart and the East Central chart, lots of variability, lots of up and downs in those charts. But if we do a statistical analysis on that data, a linear regression to see how our data going up, are they going down? Do we not have much change? What we're seeing is that we have a positive slope in our data, or that over time temperatures have been increasing over this roughly 130-year period in Wisconsin and East Central Wisconsin by about 0.2 degrees per decade. So roughly with this trend, roughly every 50 years, we've been seeing a 1 degree increase in our average temperatures. Obviously we have a lot of variability around that line. So even though our temperatures are on average increasing, we can still we see on here, we can still have years that are below average, below this long-term thick black line. But we're maybe seeing less of these years, or when we have one of those cold years, maybe it's not as cold as a cold year decades before. So just keeping in mind that there is some variability, but overall we're seeing that upward trend. And if we just piece out the data over the last several decades, since about 1950, we see an even more pronounced warming trend. In this case, about 0.4 to 0.5 degrees per decade. So going up a degree Fahrenheit roughly by every 20 to 25 years. So yes, we've been the warming trend is showing up going back to all the way to the earliest where we've been keeping records, but has been more pronounced in recent decades. So now breaking this apart season by season, these are some really great maps from some researchers at UW-Madison's Nelson Institute, their Center for Climatic Research, that look at temperature trends across Wisconsin counties going back to the year 1950. And what we're seeing across these counties is that there is significant warming across virtually all these Wisconsin counties over this roughly 75-year period across all seasons. So the little asterisks that you're seeing in those counties are counties where we can say with a high degree of confidence statistically that there is a warming trend in those counties. Warming has been most pronounced in the winter months. You can see on the Wisconsin map there for DJF, which stands for December, January, February, that we have more of those counties showing up in dark orange color. And there's a higher degree of warming that's been noted in the northern and central counties. So more warming occurring during those colder seasons and those counties that are have historically been colder. And that's a trend that we're seeing across both the Midwest and the Northeast. It's not something that's just unique to Wisconsin. So now breaking this apart by daily maximum and minimum temperatures, we see an interesting trend here, and that has been that minimum temperatures have actually been increasing at a faster rate than maximum temperatures going back to mid-20th century. Slightly, 0.4 versus 0.5 degrees of warming per decade. If you look at those two charts there on the right, and this has implications for things like relative humidity, how cool it gets during the night in the summer months, things like that. So now looking at temperature extremes, we've been talking about averages so far. What about these really cold extremes and really warm extremes? How are those changing over time? The graphs that you see here on the right are from a assessment that was done a few years back now by a NOAA partner. A lot of the data I'll be showing here today is either from NOAA or our 5th National Climate Assessment that just came out this past year. So I'm borrowing a lot of data here today and putting it into an agricultural context. So taking a look at these two charts, which show number of warm nights and number of very cold days, you can see the temperature, how we define those nights with a minimum temperature of 70 or higher, or a maximum temperature of 0 degrees or lower. On the hot extremes, we have many years that have been at or above the long-term average since the 1990s. If you just look here, I'm not sure if my cursor is showing up, but these orange bars are near or above that long-term average line, that dark black line. But there really is no clear trend. We really don't see an up or down trend in this data if we look back several decades. And summers have just not warmed as notably as other seasons, if we going back to those maps that I showed a few slides back. If we look at cold extremes, we see many years that are near or below average since the early 2000s. We see the little black dots here, which are the individual years, the number of cold nights that are cold days, excuse me, that we had. We still have some that are above average, but many that are below this average. And we're not seeing that as many of these high peaks on the graph as we used to. We're not getting above like 4, 5, or 6 of these days per year. We're kind of staying at maybe about 2 or less per year on average. And I should say these are averaged across the whole state. So there could be individual days in different regions that are getting washed out by this. And winters, like I said, have been the season with the most pronounced warming trend in Wisconsin since the 1950s. So more pronounced warming kind of on the colder end of the spectrum versus on the warmer end. And with that warming, one thing we've been noticing is increasing length of growing season. And so what we see here, this figure on the right, and if one of my colleagues could put a link to this in the chat, that would be great. This is Midwest Regional Climate Center's freeze date tool. This is an interactive map that provides data at the county level going back to 1950. Where you can look at trends in growing season as well as trends in the last spring freeze date that we had in spring and the first fall freeze that we have in the autumn months. So kind of those endpoints of the growing season as well as the length of growing season. And so what we're seeing here across Wisconsin is that a lot of these counties are showing up in green. And if you look at the legend down there, this means that we've been increasing growing season by a few to several days over the past roughly 7 decades. This data is going back to 1950. And the cool thing about this tool is that you can click on an individual county and do a data breakout by your individual county to see how things are changing for your specific location. I should say the data that goes into this tool is actually what we refer to as gridded data. It's observational data plus interpolations between observational sites. So that's where this data is being sourced from. And what we see here, if we look at this chart for, I just clicked on Winnebago County, and what we see here, the endpoints of our growing season, they're trending earlier and earlier in the spring months, and then they're getting later and later in the fall months as those freeze dates are changing, and we're getting a wider spread between those events and thus longer growing seasons. So highly encourage you guys to check out that tool in your spare time. Now let's pivot to precipitation trends, looking at things on a seasonal level. Similarly to temperatures, we've been seeing an increase in precipitation across Wisconsin counties since 1950. Same as before, those asterisks represent where there is a statistically significant trend. And we see here on the right, similar data provided in that NOAA state level assessment that was done for winter and summer precipitation. Once again, winter is a season with the most pronounced change. And we have many above average years in recent decades in winter. If we look at this chart here on the upper right, we see a lot of those black dots are above that long-term average line. And not sure if this is our highest bar or not, but it could be tied for our highest amount of winter precipitation, 5-year average for the period 2015 to 2019. And some of the same things going on during the summer months, but not as much of a upward trend as we're seeing during those winter months. So now let's turn to the extremes. We're going to look at the wet end of the spectrum first. So really heavy, impactful precipitation events where we get multiple inches of precipitation in a single day with, maybe have really intense thunderstorms or something like that during the summer months. So a couple of figures here, again, from that NOAA assessment, that bar chart on the left, and then some maps of the United States from our 5th National Climate Assessment that just came out this past year. I will say that the National Climate Assessment has a whole chapter dedicated to the Midwest with much more information than I will be presenting today. If you want to learn more about climate trends in the Midwest, I would highly encourage you to check that out. But just pulling a few things about heavy precipitation out of these assessments. We've been seeing bigger rainfall events. They've been becoming more common across the Midwest and the larger U.S., both in terms of frequency, so how many of these events that we get in an individual year, and the amount of our annual precipitation that actually happens during high impact, heavy rainfall events. So a higher fraction of our annual precipitation occurring during heavy rainfall events. And just looking at Wisconsin in particular, over the last 40 to 50 years, on average, has been an increase of about 1 day per year. So the average number of these days we get per year has gone up by about 1 day compared to the late 1970s. And we can see here on this chart on the left, we see those teal bars. We see upward trend in that data. Again, lots of variability, but averaging out, we see that we have that upward trend in the data. So pivoting now to the dry end of the spectrum, looking at drought and how often we get drought. These charts show drought severity categorizations from the United States Drought Monitor, going back to the early 2000s for East Central and Northeast Wisconsin. So we see a lot of times, you see how spiky, if you will, this graph is. We can see, there's plenty of times on here where we had times where we were in severe drought or extreme drought, and most of these regions had some kind of drought going on in them. And then how quickly we can go from having almost the whole area in drought to having no area in drought at all. How quickly we can go from one end of the spectrum to the other, that variability that we talk about. And I just want to show here this box, picking on 2023 in particular is a good example of what we sometimes refer to as weather whiplash, going from one climate extreme to another over a very short time period, like that spikiness in the graph that I was just talking about. These maps here on the right show precipitation ranked by the different climate divisions across the state of Wisconsin. This is basically looking at, in this case, how 2023 compared to the rest of the Februaries on record or the rest of the Mays on record. How does 2023 stack up compared to those other 130-ish years? And so what we see here is that February of 2023, East Central Wisconsin, these counties outlined in this thick black line, ranked as the fourth wettest on record. And just to the south, Southeast and South Central Wisconsin actually had their wettest Februaries on record. But then just a short 3 months later, heading into the late spring, early summer months, things really switched. And we went from having the fourth wettest February on record to the 12th driest May on record. And we can see here in this chart how we went from having no drought in early 2023 to getting into almost all the area being either abnormally dry or in some kind of drought by the time we got into the summer months. And as we get into the summer months, our moisture demand is getting higher as plants are beginning to grow and temperatures are warming. So it wasn't long before we started to see some drought in this area. So that's observational data. Now let's pivot to some projected data. So the same group out of UW-Madison who looked at observational data did some work with downscaling climate modeled data for mid-century for Wisconsin under a moderate emissions scenario or a scenario where we are increasing emissions, but maybe not at a as rapid a rate as like a higher emissions scenario. We're seeing continued increase in annual temperatures with increase across all seasons. So similar trends to what have been observed and maybe even a little bit more pronounced if under higher greenhouse gas emission scenarios. We can see that here in this chart here that I've picked out from Outagamie County from this climate toolbox tool. And you can see here this blue line versus this red line, how temperatures are projected to change under different emission scenarios. Under higher emissions, we can expect our greenhouse gas levels in our atmosphere to be higher and more heat being trapped in our atmosphere, and thus temperatures warming at a faster rate compared to lower emission scenarios. So a lot's dependent on what emissions are going to look like in the future. With reductions in very cold nights and increases in hot extremes, like more warming on the hot end of the spectrum versus on the cooling on the cold end of the spectrum. Pivoting now to precipitation. Annual precipitation continuing to increase with increases across most seasons. Similarly to what we have been observing, highest increases during the winter months and the spring months. Summer is a little bit more uncertain, depending on which emission scenario and time period you're looking at. There might be very minimal change in summer precipitation, or even some projections are projecting a decrease during the summer months. And then increasing frequency of heavy rainfall events and the amount of precip received during those heavy rainfall events. So similar trends to what we have been observing. And as we look ahead, like the variability that I've referenced several times in this presentation, this is a great figure from a study that was referenced in the Midwest chapter of the 5th National Climate Assessment that talks about how often we go from having in a month-to-month period, how many times in a year we can go from one end of the spectrum to the other for precipitation, really dry to really wet, or vice versa. And what this study showed using some modeled climate data is that as we increase emissions and things warm at a faster rate, we can be expected to see more of this flip-flopping between really dry and really wet, or vice versa, just like from one month to the next. Yep, and those just some bullet points on what I just said. So now I'm gonna pivot here to so that's what I have for the climate data. And again, I went through a lot of that very quickly, and we can address some of the questions you have in the discussion section. But now I want to get into impacts and adaptation mitigation strategies. So a lot of the information that I covered today comes from this document that we published just a little over a year ago now, Climate Change Impacts on Wisconsin Agriculture. And the goal of this document is to inform farmers and those who advise farmers as to how climate is projected to change. So a lot of the information that I just went over is in this document. What will the impacts be on agricultural operations in the state? And then what can be done to help adapt to and mitigate those negative impacts? This bulletin's available on our Midwest Climate Hub website. That QR code should take you to that, or if one of my colleagues could post a link to that in the chat, that would be great. And the great thing about this document is that we brought in a lot of local expertise to provide state-specific knowledge and guidance into these bulletins. At the Midwest Hub, myself, I'm a meteorologist by training, so a lot of my background is in climate. But we have a lot of folks in the state of Wisconsin who have expertise in a wide range of agricultural topics. So we were able to tap into that to this document. So I think that's one thing that really makes this a very useful tool. It's roughly about 10 to 15 pages in length. Think extension style bulletin. It's not written as like an academic journal article. It's meant to be something that can be easily understood by the general public. And yes, it's available as a PDF on our website. And as a spinoff to this, we, for those of you who grow specialty crops, we have some specialty crop bulletins and resources that I've been the lead on helping to put some of these together as a spinoff to our state documents, where we don't get into any agricultural systems too in depth. But with these resources, we dive a little bit deeper into specific agricultural systems. For example, like we have here for Christmas trees, that we wrote with some extension experts at Michigan State University that came out last year. And one that's just come out within the past few weeks, climate impacts on tree fruits and viticulture in the Midwest region, that we wrote with Amaya Atucha and her colleagues at UW-Madison. And this is a work in progress with more to come soon. And that QR code will take you to the website where these are housed. So very briefly, just for the sake of time, we can obviously talk much more about this during the discussion section, but I wanted to pull out some of the key impacts on crops, soils, and animals that we discussed in these assessments that we wrote. I'm just going to throw some of them up here. I'm sure these are things that you have some familiarity with. Maybe some of you have experienced these on your farm. I want to pick out two in particular that were called out in the 5th National Climate Assessment. The one up there on the right, that picture of apple blossoms, that's an impact that can happen. We have erratic freeze-thaw cycles during the winter months. So if we have say a warm stretch in March, followed by a hard freeze after the blossoms have already come out, that can be very detrimental or even kill a year's crop for fruit growers. This was an example of a bad event that happened in 2020 in Michigan. This figure down here in the center, this is showing how runoff could be impacted, the amount of runoff by changing precipitation and temperatures. So looking at those different scenarios, and that even under the RCP 4.5, which is a lingo for a intermediate emission scenario, so not the highest, but in the middle of the road, that even there with increases in temperature and precipitation, especially during those winter months, erosion could become more of an issue, even as early as middle of this century. So thinking about how do we protect our soils during those times of year looks to become more critical. So I cover a lot of information, and sometimes I feel like I'm, overwhelming everybody. A lot of bad, things that sound like bad news. But I want to wrap up my my presentation with a few slides just on some farm level solutions, some things that that are science backed that show that can help to increase climate resiliency and even help to mitigate future climate change. Just to show there are things that we can do about this issue. These are some great graphics here from the Rodale Institute, their farming systems trial. Shout out to them for these. And if you scan that QR code, that will take you to Rodale Institute's Midwest Organic Center. It has a lot more information than what I've provided here. I just wanted to provide these graphics to show some of the benefits of improving soil health. We hear about improving soil health and practices that can improve our soil health. This study just aimed to quantify what are those benefits to some degree. So we look here, the graph that shows soil health score and the different management systems, conventional versus legume cover crop versus an all manure fertilizer system in a grain cropping system, and how that impacts soil health score, also between full tillage and reduced tillage. But the main takeaway from this is just to see how with improving soil health, and these letters represent significant differences across these systems, you can see how things like water infiltration rate and microbial biomass carbon in the soil improve with improving soil health. So thinking about things like how we infiltrate water during high impact rainfall events and store that water during droughty periods, preventing erosion with strong soil aggregates and root structure during those high impact events. And then thinking about mitigating future climates and drawing down greenhouse gases, capturing carbon in the soil through improved biomass and microbial biomass carbon. Just a few notes on the value of crop rotation and crop diversity as a climate resiliency strategy, again from the Rodale Institute. So things like conservation crop rotations, cover crops, tillage reduction, greater use of perennial forages or other perennial grasses. These are all things working into the system. These are all things that can act to help increase soil health to get some of those benefits that I was just showing on that last slide. Diversifying to hedge risks of potential crop failure. So if if you have a diverse portfolio of crops and things that you're growing on your farm, you're not putting all your eggs in one basket, if you will. So having if one crop or one part of your system fails, you'll have something else to fall back on. So just thinking in terms of that. And then taking advantage of that longer growing season. If we have a longer growing season, this could allow for things like planting earlier, if conditions allow, if it's not too muddy or that kind of thing. Adding new crops into the rotation, maybe more diverse cover crop mixes, things like that, or even options for double cropping, something that with our climate in the past maybe wasn't feasible, but maybe in the future it could become more feasible. And then helping to break up some pest and disease cycles with just providing the example of what can happen with a allelopathic effect if you add a small grain into a corn soybean rotation. And I'm going to take a guess that might be some grazers on this call today. So I wanted to point out some of the climate benefits of rotational grazing. You know, this is a perennial based system. So thinking about those root structures and that longer period of year where we have growing vegetation on the surface, all things that are going to be good from a climate standpoint. Rodale points out here that grazing encourages plants to send out more and deeper roots. So as that top level biomass is being grazed off by the cattle, that's going to encourage more below ground growth, and that the litter is going to the dead plant material will be decomposing. So they'll help create some good soil aggregation as well as sequestering carbon, as that a large portion of that plant biomass is carbon, and that's being stored below the soil. So pasture management practices like rotational grazing or maintaining diverse forage covers, or if we have areas where there are where cattle tend to congregate, like on a farmstead or like a watering source, things like that. Thinking about some all-weather surfaces and high traffic areas that can help make livestock systems more resilient to times of drought and excess moisture. Um, I am not a grazer. I have very limited grazing expertise, so I would love to hear more for those of you who are grazers of some of the practices that you've been doing during the discussion section and how they have been working for you. And then thinking of shade structures as well, either man-made or through trees in a pasture, as to help reduce livestock heat stress during some of those really hot days in summer, if we are to get more of those days in the future. Thinking of ways to integrate perennials into your landscape. Again, you know, with that, like I've been mentioning several times now, with that below ground carbon, that root biomass, prairie and natural grass systems have a very robust below ground profile. Be excellent for the soil. When I was working for Pheasants Forever in Southeast Wisconsin, this was a slide I would often show to producers who were thinking about putting perennials on their farm, either through prairie or pasture or trees, just to show how robust some of that below ground biomass can be. So as a precision ag and conservation specialist with Pheasants Forever, I was working with farmers to help them find ways to convert low profit annual crop acres to a permanent perennial cover, whatever that looked like, that helped to meet their farming goals. So that's an option. Looking to create some habitat diversity through to promote beneficial insects and pollinators, having more space for those beneficials on your farm. Incorporating trees through alley cropping or other agroforestry practices, you know, along with prairie grasses, trees have deep roots as well. They're going to help hold that soil in place. And then, like I've already said, these are a great opportunity to sequester carbon. And my last slide here, before I share some helpful links and we turn it over to our discussion and question time, I just want to put a few notes in here about farm worker health. So those of you who spend a lot of time out doing labor either on your farm, or if you have those workers on your farm and you're concerned about worker health and how climate is going to impact that. There's some great resources from the University of Nebraska's Center for Ag Safety and Health. I just have listed a few of their fact sheets there. And I should note, we'll be sharing these slides with Aaron and Aaron after this, so they will have all these links. So don't worry about trying to take screenshots or scribble these down. So just some impacts that we covered in our Wisconsin assessment. So those who predominantly work outdoors are particularly vulnerable to heat-related illnesses during very hot days, hot and humid days. And then if there is to be an increased need for chemical treatments to address pest and weed impacts. So if we have new pests and weeds moving into the area with a warming climate that were traditionally found further to the south, or more favorable environments for ones that are already here, there might be more a need for changing our chemical treatments if chemicals are something that you use on your farm, and that may lead to greater environmental and human exposure to such chemicals. So thinking about things like providing shade, improved personal safety equipment, drinking water, and alternative working hours, if that is something that would be feasible. So with that, I won't spend a lot of time on this, but these are just some links to Wisconsin climate resources, a lot of data sources that I pulled from today. A lot of this information isn't original data for the USDA Midwest Climate Hub, but data that I've pulled from our various partners across the Midwest. So any one of these links has way more information than I've covered today and is a great resource for you. Also some resources for farmers if you're thinking about any of these, working more with any of these practices on your farm. And so with that, I'll just leave up my contact information as well as our contact for our director, Dennis and Lori. And I think we'll pivot over to some questions now and discussion. Thank you.